All right, everybody, this is Mr. Wyrick. I'm going to be going through the areas of regular polygons notes with you. Excuse me, sorry. This is going to take a little bit of time and effort, so make sure you're focused up, working hard to get it done. It might be tough to follow the Delta Math instructions, so here we go with ours. First off, inscribed and circumscribed. If you ever see that, if a shape is inscribed in a circle, that means all the vertices of it touch that circle. But if they're talking about the circle, they say the circle is circumscribed around that shape. Then we have the apothem. If you have the apothem runs like this. It goes from the center to the middle of a side at a 90-degree angle. Now, if this looks kind of familiar, that's because it's basically like the altitude of a triangle right here, except you're probably going to have to use trigonometry if they don't give you the apothem in order to find that apothem. That segment drawn from the center, perpendicular to the side of the polygon, and then the central angle. We already know about central angles. We've been looking at the angles of the polygon. So like when we were looking at this one, if it's a pentagon, we have 180 times 3. So that's 540 degrees for the whole thing. We divide by 5, meaning each one of these angles around here, A, B, C, D, E, is 108. If we cut that 108 in half, then right here on angle B, these are both going to be 54-degree angles, and we could use that to find this central angle. There's a quicker way, because this is 360 degrees around the circle in the middle. If we just take these and say we want to find the central angle, we can find it by using 360 divided by the number of sides. So 360 divided by 5 in this case means we're going to have nope, just lost it for a second. 72. So this central angle here is going to be 72. When we cut this in half, that's a 36-degree angle. This is a 54-degree angle. That's a 90-degree angle. So we can use trig and those angles there if we have this radius or if we have this full side of the shape. In order to find that apothem, then we can find our area of the whole thing. On our example here, in the figure regular hexagon, JKLMNP is inscribed in circle R. Identify the center, radius, apothem, and a central angle of the polygon. Find the measure of the central angle. So the center is going to be here at R. A radius is going to be either RK or RL, but not RS. RS is the apothem. And you can see the difference. That RK goes all the way out to the edge and touches the circle. It goes to the vertex. The central angle is KRL or LRK, or we could just call it angle R because it's the only one shown here. The measure of this central angle, I like hexagons for this reason. We have 360 divided by 6. This is a 60-degree angle. So when we cut this with the apothem, we're making a 30, 60, 90 right triangle. So we should already kind of know, if we know any one of these sides, what the other ones are going to be. Just a reminder on SOHCAHTOA, if you want to use sine, cosine, tangent to find that, sine is the opposite over the hypotenuse. So if we're going here, opposite hypotenuse, we would not be finding the apothem. But if we know this angle here at L, we could use sine with opposite over hypotenuse. Okay. Cosine is the adjacent over the hypotenuse. So if we're using this angle, we would know this radius. We can find this, or sorry, yeah, we would know this radius. So this would be adjacent over hypotenuse there. And then tangent would be opposite over adjacent. So we'd really need this one down here in order to get that RS, that apothem. Okay, if we're looking at this one, here's our practice problem. The cover of the hot tub shown is a regular pentagon. If the side length is 2.5 feet and the apothem is 1.7 feet, find the area of the lid to the nearest tenth. So when I was in school, we didn't have any kind of fancy formula. What you would do is just find the area of this triangle, 2.5 times 1.7 divided by 2. and then we would multiply that by 5 because there are 5 of those exact same triangles. But we have a formula here, and it's this: 1/2 the apothem times the perimeter. Again, the perimeter is going to give us the base of all of those triangles. And then the apothem is something that we either find, or maybe they're really nice and give it to us. And because they're triangles, we need that 1/2. Okay, so this is our big time formula: 1/2 the apothem times the perimeter. You may have to find apothem. On this one, find the area of the regular polygon, round to the nearest tenth. We would have to create the triangle. We would need to create the apothem. So this 25 would go down to 12.5. Again, it's a pentagon. So 360 divided by 5 would be a 72. So this would be a 36-degree angle. So we would use the 36 and we would use the 12.5. That would be opposite over adjacent. We could use tangent there to find that apothem. And then 25 times 5 would give us our perimeter. Similar kind of thing here, except this time we're given the apothem. We're not given the rest. So again, this is 1, 2, 3, 4, 5, 6. This is an octagon. We would need to create the triangle, find an angle so that we could find part of this outside, and then the whole side, and then multiply that by 8. That would give us our perimeter. We multiply by the apothem. We divide by 2. The delta math, if I can find it real quick, 5,9, area of regular polygons. It's not going to pop up immediately. I've limited this to just given the radius, find the area, or given the apothem, find the area. So you go to the problem, and you can see they give us the apothem on this one. We know it's a dodecagon, so that's, I believe it's 12 sides. 1, 2, 3, 4, 5. So yeah, 12 sides. 360 divided by 12 is going to be 30. So this would be a 15-degree angle that we can use to find the side down here and do the math that way. Okay, so take your time, work through, make sure you're using the formula. If you have questions, save those, and we'll address them when I come back.